Hey guys, today we are going to talk about a topic that is very near and dear to all of us, and that is gravity. Okay? Now, gravity is actually pretty easy to explain. Gravity is simply a force. Now, we're not meaning the same type of force that is in Star Wars, where someone can, telepathically do some crazy magic and stuff like that. But actually, Star Wars isn't that far off. You see, in Star Wars, they can push and they can pull objects to them. And actually, that is the scientific definition of a force. It is a push or it is a pull. Gravity works along the same lines. You see, what happens with gravity is every object. It can be, any object. It could be you, it could be me, it could be, here's me. It could be my pet cat. I'm not very good at drawing cats, but whoop. It could be a little tiny marble, or it could be the Earth itself. It has gravity. Now, the bigger the object, the more gravity it's going to have. So, for instance, this little kitty cat is going to have more gravity than the marble. But the human is going to have more than the cat. So, then why don't we see this on our planet? So, the reason we don't see this on our planet is pretty simple. And that is simply because Earth is far too big. Everything on Earth is pulled to Earth, whether it be you, me, the cat, the marble, a house, doesn't matter. It's all getting pulled down towards Earth. Now, Earth out in the solar system is actually being pulled towards something else. You see, Earth gets pulled to, let me turn that off. Earth gets pulled to the sun in the middle of the solar system. That's right. Now, we know that the planets go around the sun, and that's because of gravity. You see, as a planet, I'm going to put a little E here for Earth. As a planet goes towards the sun, so it's going towards it, it also gets kind of flung around it, and that's what creates an orbit or a revolution. Okay, not a rotation, it's a revolution. Okay, rotation is when an object spins. Okay, so the Earth rotates every day, but it revolves around the sun once a year. And again, it's revolving because of gravity. Now, one of the cool things, at least to me, I think about gravity is, here, let's go back to this picture I drew earlier. I'm just going to put, this is the Earth down here. If I was standing here on the Earth, I could do something kind of cool. Now, I could, let me show you what I mean. I could actually take and, let's try and do this right. I could take and I could go bounce. Didn't do it quite right. But I could jump. And this jumping motion is actually a way to overcome gravity. Here, I'm going to put him back so his head at least goes back on. Now, when someone jumps and they go jump, they are applying a force. They are applying an upwards force. Okay, so they go from here on Earth, which is when they are being held to Earth by Earth's gravity. When they jump, they are applying an upwards force. But we don't just stay up here. No, we come back down. Because what happens is Earth's gravity is always pulling on us. So that is always acting on us. Whereas when, I'm pushing buttons. So Earth's gravity is always pulling down. But your jumping force only happens once. So it's enough for you to temporarily get rid of gravity, or something that is called overcome gravity. But it doesn't last forever, because Earth's force is continually pulling down on you. You're always going to be pulled towards Earth. Now, if you were out in space, then let's just imagine for a minute that you could be completely out in space, where there was no planets, no sun, no black holes, nothing around you. It'd be kind of cool. Here's what would happen. Let's say you were here, and suddenly you've become a half giraffe because you have a giant long neck. And let's bring back that cat. Okay, so here's that cat again. Okay, now, obviously the human is bigger than the cat. So what would actually start to happen is, in space, you get pulled towards other objects. So this cat would actually begin to move towards the human, just kind of like this. Okay? Now, the cat would move faster than the human would, and the human would move slightly towards the cat, move a little bit, while the cat moves closer to the human, and the cat would move faster. But they would both end up coming together. That's because of gravity. Okay? Now, usually the bigger the object, or the more massive the object, the more gravity it will have. So in space, mass equals more gravity. Okay? So the more mass it has, the more gravity. Now again, like I said, that's mass. I'm not referring to weight. Keep in mind, weight is just a number we assign to the number, or the amount of mass an object has, times the gravitational force of the planet. Now, on our planet, it's one thing, and on another planet, it's going to be something else. For instance, the moon has about 1/6 the amount of gravity that we have. So if you weighed 60 pounds on Earth, 1/6 of that would be 10 pounds. So on the moon, you're only going to weigh about 10 pounds. But you still have the same amount of mass. That doesn't change. So when we're talking about objects in space, again, mass. So let's review real quick. Gravity there we go. Gravity is a force. For us, it pulls to Earth. Oops, I should probably do the correct thing and make that a capital letter. It pulls to the Earth. You can overcome gravity. Overcome by applying a force in the opposite direction. Now, let's look at one thing. This is kind of like a bonus. This is what you need to know for gravity, but I got a bonus for it. So, I want to show you something. If we look at an airplane wing, it is shaped like this. Okay? This is a shape that allows air to create something that's called lift. You see, gravity is always pulling down on that airplane. So what happens is, as this airplane goes forward, the air is coming backwards towards it. And as it starts to flow over this, and it goes under here, it creates something that is called lift, and it allows it to go up. So it counteracts the two, or the forces of gravity pulling it down. It only works, though, when it's going forward. If that plane were to stop going forward, that air would no longer be going over that wing. And that lift would go away, and the only thing that would be left would be the force of gravity. I'll put G for gravity, pulling it down. Okay? So that's all you need to know for today for gravity. Again, this has been Mr. Bishop helping. If you need any help, please send me a message, and I'll be glad to help you. Bye.